Welcome back to Frankly Developing. In this video we continue from the last one. If you haven't seen it, go watch it first, because we took a look at the GitHub repository and reviewed the code, and we found a problem there with the tell don't ask principle not being really adhered to. So we took a few preparatory steps, but we didn't quite manage to complete the work on actually using this tell don't ask principle in action, which is what today's video is going to be about. So stay tuned to see the tell don't ask principle in action. Quick recap on where we did last time and the state we are in here, which is this game state enum that encodes all of these different states in the game you could be in. And then we found that it matches up with individual classes, so one class per enum basically, which is kind of odd because you have the classes already, so why this kind of redundant enum? And then we noticed a few switch statements. Like this one still left in the update. It looks at this enum and switches over this enum for the different states and then does something called update on each of them. But then it goes on to set like the new state, and we already changed this a little bit to immediately have the state enum like before, but also a current state that's actually one of these classes. So introduce the common interface for these so we can assign it to the same variable each time. Like, yeah, this is going to the level selection, this is going to the editor, to the settings screen, and so on. And one of the switch statements we already completely removed. That was in the draw method, where now instead of a big switch like this, you just have the draw call, because all of them, these interfaces provide the method. So each game state you are in just has a draw implementation, instead of switching over these and calling each one on its own. And we said the tell don't ask principle is violated here because when you look at what's happening here, you have like a settings object which encapsulates this settings screen, and then you go to it and call it update, but afterwards you retrieve all its data like credits button, back button, and if you look into this, these are like publicly accessible things from the settings screen. So we kind of violate this idea of encapsulating it by taking all that stuff out again and having the logic outside of the main class of the settings screen. So here's the logic that basically controls what happens when you click somewhere in the settings screen, which is just in the different place, which also makes this switch statement really, really long. And so this time we're going to look at how we can use the tell don't ask principle to tell this settings screen class to do all of that for us and not having to do the logic here in this main class, in the non-sharp game class. So step one is eliminating this enum. We don't really need it. As we said, like this state is now particularly redundant to our current state, which is the iGame state, which contains the actual objects that can hopefully with tell don't ask do all the work for us. But now this is almost not used anymore, and if you look at the usages, all of these are inside of this big switch statement in all the different places. And usually, as you can see here, we already have each of them mapped up to what we did on the other version. So with the new state, we have the different menu options and everything in place. So instead of now switching on the enum, we can write some code which looks actually really bad. Temporarily we can check something like this instead of switching to the game state.game and then work with the play object. We can just check if the play object is the current state, which is now equivalent. So all of this can basically go in here. And then for the next one, similarly we have the main menu object. Check if that is the current one. And all of this can move in here. Same thing for the other cases. Okay, so once we're done with replacing all these cases and taking all of that code out, we can basically remove the switch statement, and we have a big chain of these kind of ugly if-else-if cascade here with all these different things. But now you start noticing as well, like we're already talking on the current state and it's being played, so I can call the update method on this. So, and if it's the main method, I can call the update method. If it's the level select, I can call the update method. If it's the editor, I can call the update method. If it's the settings, I can call the update method. If it's the credits, I can call the update method. So the pattern becomes much more apparent already. And now the next question is, how do you approach this, replacing it? Because the update methods, if you look a bit closer, they have like different arguments here and there. Sometimes they output this new game state, sometimes they don't. Some have like a level metadata ref thing going, so there's a little bit of a difference between these individual update calls, which makes it a bit harder to introduce them into one common interface. So let's start to introduce the interface. And don't forget to subscribe to the channel if you like this sort of walkthrough and hands-on demonstration. So we see here the update call. And for the credits, we already implemented this iGameState. Right? So credits, for example, derives from iGameState. And if you look at this update call and what kind of arguments it takes, we can try to move this into the interface. And say like, yeah, why not have all of them satisfy this kind of upgrade, right? So it works for the credits already, but for the others, maybe not so much. So if you look into the settings screen, it's not satisfying this interface because it takes an additional graphics device. Well, that is easy to incorporate, right? So by going there and saying, why not just have everyone take this additional graphics device? Then we have to go back to the credits, because now the credits don't work anymore, and introduce it here as well. But you can just ignore it, so that's fine. And if you go back to the next one, that will be the variant where we have like this out game state. So again, it's some addition that you can set and use, and you don't have to, so that is easy to incorporate as well. So for the time being, let's just add that. Of course, this is the enum we want to get rid of eventually, so this will probably not be a final thing. Now we go back from the initial classes and adapt all of them again. Like the credits we already checked, but yeah, it still needs this parameter. Just ignore it, so it satisfies the same interface. And so does the settings screen. I can see here in the call we also need the game state like this, which you can also adjust down here to have these. And yeah, we don't use it, so just use the underscore in C#, explicitly state we ignore it. Oh, and now there's a metadata ref. That's quite special for the level select, so okay. But we can still do the same trick. Like, let's just add it and see if we can get rid of it later. And again, we have to update all the implementation classes as well. You notice that for some, we have a really different structure. We don't have this game state out and we have this leave. Maybe we don't know what to do with that yet, so you can just leave it and implement this method because we're not yet really calling this interface method. It doesn't matter at this point. And of course we have to change the initial calls as well. And you notice how we're introducing a lot of new stuff that looks like bad code temporarily now as a work in progress to unify all of these calls. Because at this time the update method between credits is the same as for settings, as for editor, as for the level select. And the only one, oh no, actually main menu is still the same, and the only one that's differing still is this play update. And it's kind of strange because it has these different properties, with the focus is active and the leave. But we see that the leave is actually used to set the next game state, which is the same idea that this new state has. So now we can just take the same approach very dumbly introduce these two parameters and just ignore it in all the other cases. Or we can check if it's easier to rewrite this immediately to the game state to make it even more similar to the others. If you look at what's happening with this leaf, it's initialized to false, then true and return. Okay, here true and leave game. What does leave game do if you return true here? Reset some stuff. Okay. So if we had like this out parameter, like in the version above we have here, well, we could probably set that as well, because we know that if this is true, the state is the level select we want. Which means on these update methods we could just replace that out bool leaf with the game state. And on the calling side, now the last difference is this active, and of course we can add the level data, ignore that. So let's see what happens to the is active, or has, oh, it's called has focus here, so kind of renaming. And it's only used here in the end. There's some conditions, so maybe we don't fully understand what's going on here, so let's take that last one and just pass it into the interface method as well. And then go back to all the implementations and fix the compilers there. Now we also need to unify the call sites. And at this point, we are pretty strongly unifying this code. It looks almost exactly the same everywhere, except that we're calling it on different objects. Oh, messed that one up. It's almost the same, except again, as you said, the name of this object differs slightly. Right. Sometimes we ignore these parameters, we don't need them. Sometimes we use all of them or most of them. It doesn't really matter to us, but we notice some shared commonalities, like this level metadata is just created to be given there. And it's really only used by one, but that'll clean up eventually, so we can just move that to the top and remove it from each of those ifs, because now we're in the process of realizing that we did all of this bad code to get to a state where we can quickly get it all back together. And same thing now for all these different objects calling the same method. We can actually use our interface, because it defines this method, to replace that and have it on the current state. And now you also notice that no matter what current state we are in, the first line is already exactly the same for each of those. So the next thing we can basically get out of all of these ifs is we pick this line first, call it, and then since we don't change the game state, it's still the same, we can do this follow-up logic that we're not that happy with yet. But let's leave that one and get it down. Oh, sometimes it's called game state, sometimes new state, so missed that little difference, which is really easy to fix. Just call it game state. And there you go. Now there's only this custom behavior left for each of those, and one shared update call. Now let's move more towards tonal task. If you look at something like the credits, we have like a similar pattern again. You call the update method before all these ifs, and then you check what the user did, like clicking the back button, and set a new state to be in, like the next game state. Back from the credits apparently gives these settings as the current state. And similarly on the settings, you have this thing like if you press the credits button, you move to the credits, but if you press the back button, you move elsewhere. So to unify these things even more so we can see what they have in common and extract that into one single piece of code, there are a few things that deviate, which we need to handle first. So some like these we can now in detail.ask concept move into the state. So all of this information is available inside of the settings object clearly because we get it out from there. And so this call can easily, it's a static call anyways, be made inside as well. So we don't have to bother about it. This one's a little bit different. We have to look at how it's used, how we can replace this. And let's just clean that up a little bit and make all these different cases similar. Okay, at this point, pretty much all of them are similar, except for a few calls that are left that actually refer to the other game state objects. Like if you press the play button from the main menu, the level select is being called with find levels. Or if you have the level select state and you start the game, it's loading the level metadata for that game. So let's take a look at how these different game states are dependent on each other. So normally you would do this in your head, but let's walk through this slowly now. You start with the main menu where everything begins. From there you can, for example, go to the settings. And we know from the settings you can go to credits. And back and forth between all of these. So credits goes back to settings, goes back to main menu. And then we have the level select, from which you can pick a level and then play the level. You can go back each time, and also there's some editor state. You can also go back. So that's already our hierarchy. And you can see it all starts with the main menu. So the goal would now be to have our main class only know the main menu. So we want to cut down on the number of dependencies, because dependencies are always bad for us in software development. We don't want to have dependencies to everything in the game if the main menu is sufficient, and that can handle all the follow-up dependencies. One problem that we have to solve is basically how do we deal with the cyclic relations on credits going back to settings, going back to the main menu one step at a time. So if we look at these few lines that were kind of the problematic thing, we notice that if you are in the level selection, you need to call something on the play, which is you select the level and you go to game state. So it's kind of exactly where you want to go. And same here, if you are in the main menu and you want to play, you need to do something to the level selection, because once you go from main menu to level select, some initialization needs to happen. So the interesting part now is to look at how does it matter that these objects are generated initially. Right now they're all generated at the same time in the beginning and kept around. But is it really necessary? Do they have that state that is remembered between open and closing them all the time? And well, they are initialized to something here. And if you look at all of these things, it seems fine to just regenerate an object of that kind, because it doesn't have any important state really that you want to keep across these things for these things. Otherwise you might want to do a little bit of a different design, of course. But let's take the simple route here if it's available and say like all these shouldn't really store a lot of state. If you click on them again, it's a fresh settings screen, it's a fresh credit screen, no prior things needed. Which brings us to the point that these remaining things here are literally just the returned object is the new state, and we have the iGame state, the polymorphism in play, to have an interface to represent all of these objects. Which means when you call up the main menu and you click the play button, you can actually create a level select object and return that as the next one. So what we're going to do is we're going to change this interface to now on the update return to us either null if you want to stay on this game state or a new game state. And of course that means we have to fix all of the implementations. Most of the times we will return null, like here in the editor, but sometimes we want to switch. So if you click the back button, the new state is the game main menu. So we can return a new main menu instead. And usually we have to take this piece of code that looks at the button being clicked, which, remember, was part of this if-else-if stuff that is now happening inside of this update method. I'll just say if we are in the credits, we go back to a new settings screen. Now, an interesting part is here inside of the level select, where you have the play button clicked to start a level. Then we have a new play state, but remember that in the main non-sharp code we noticed in the update switch. So here, if you notice, we are in level select, and then we need on this play object load that level metadata get path kind of thing, which we can now do in our update when we decide to return this new play state. We kind of need to do this very same thing here. Finally, let's bring it all together. We're not yet using this resulting game state that we return. So let's see here if the current state that we call is now returning a new state. Then we can actually change to this new state instead and move on like this, which means we covered pretty much all of the cases. There's like one case that was left over, which is the main menu quit button. That could be realized in a different way, but let's keep that one here for the time being. So if we are still in the main menu and the quit button is pressed, we still want to be able to exit. All the rest is now handled inside of these objects. Like all of these things are done inside. So no more switch, just one update call. Gives you back the latest state, and that's really it. Nothing else to do. Except here the special main menu version. Again, we could change this to not return null. For example, you could return this, and null could mean that you want to exit. Lots of different options you can do. We want to check if it still all works. So looks good. We can still go there. We can still do all these things. Navigate around, back, settings, and credits. It's all still there, perfectly fine and working well. Back into the code, we see that most of it has been cleaned up. We have several of these enums already completely unused, but most importantly, most of these actual objects are still unused. Like the main class, as we said, should know the main menu, and that's about it. For the editor, there seems to be like a little piece of code that's still here. That's something specific where it's not clear to me yet why this is happening here. Can probably be moved until lost in the same way to the editor itself, but you can see that we already are at the point where we can literally delete all of these dependencies and avoid their needless creation in the constructor. So now you're down on several dependencies and have simplified this class, not just with the switch statements being a little bit smaller and simpler and nothing to do there. You also remove the knowledge of other pieces of the code base from this class entirely, which is the more valuable thing really. And that is something that tell and ask helps you to do, because you just tell other objects to do everything they need to do to make all the things work. From the main menu, you just can do everything else, so you don't have to know what else you can do. If you extend your menu, you don't have to touch this class again. Only the main menu needs to know what's directly reachable. And as you can see with the credits, the main menu doesn't even know about the credits because it's part of the settings and somewhere beneath that. So this is like really the power you get from this by eliminating all of these nasty dependencies. As you could see, tell and ask is a really powerful principle to reduce the amount of dependencies you need, because you can just tell things. It also collocates this code and behavior that you're doing with the data that it's working on. It's a very nice encapsulation result you get. And I hope you like this kind of code refuse. If you do, there are a few more refuse that you can take a look at. And please subscribe to the channel if you liked it. Thank you very much for watching. As always, have fun developing.